Welcome to our Chapter 4 Interactive Study Guide, Flipped Classroom. I'm going to go through some questions from the Chapter 4 test that's in the textbook and a couple other extra questions just for some last-minute practicing and studying. Go ahead and you should have out by this time a sheet of paper and a pencil. Feel free to pause as we get to each question. Give yourself a chance to solve it first. Then push play and you can hear me explain each question. Let's start with number 1. Finding the area of the trapezoid. To solve this, we need to use one of our two variations of the formula. Area equals 1/2 times the quantity of B1 base 1 plus B2 base 2 times the height. This is the one I use more frequently, but the other variation of the same formula is area equals the quantity B1 plus B2 times H divided by 2. So if we look here at the 5 and the 7, we realize those are the two bases because your bases are always parallel to one another. So I'm going to plug in to my formula. 1/2, 5 plus 7 is 12, so times 12, times my h to the height, which is the 3 kilometers. The height always is a straight line that meets perpendicularly between your two bases. So half of 12 right here gives us a 6, and we're left with 6 times 3. And of course, the area for this question equals 18 square kilometers. Don't forget, area must have square units. This next question here looks like a little purse, but really it's just a trapezoid. If you outline it, you can see the basic shape of it is a trapezoid. I'm going to use the same exact formula and solve it the same exact way. I'm going to add my base 1 and my base 2, 8 plus 12, which is 20. So area is going to be 1/2 times the quantity of 20 times the height, which in this example is 10. I'm going to take half of 20 right here, which leaves me with 10, and multiply by the height, which is another 10. So the area is going to equal 100 square inches. Next problem is a composite figure. And to find the area of any composite figure, we want to break it up into more familiar shapes. So I'm going to cut it right here. And when I cut it like that, now I have two parts. I have a triangular part, and I have a rectangular portion on the bottom. Find the area now of each individual piece, and then add them together. So I'm going to find the area of the bottom rectangle first. The area of a rectangle is just the length times the width, also known as the base times the height. And we have 10 times 8, which is going to give us 80 square inches. The triangular piece, I know if the bottom rectangle is 10, that means this blue line I drew has to also equal 10 inches. And the height they're showing me from this blue line to the very tippy top of the triangle is 6 inches. So the formula to find the area of a triangle is 1/2 times base times height. So half of 6 is 3, and 3 times 10 is 30. So the triangular portion is 30 square inches. The whole figure is simply 30 square inches plus 80 square inches, which leaves us with 110 square inches is our total final answer. That is the area of the whole shaded figure. I'm going to use the same concept, and I'm going to break this figure up into more familiar shapes. I'm going to cut it right here, so I have a square on top, 5 by 5, 25 square feet. And now I have a trapezoid on the bottom. The bottom of the square is also 5 feet, because all four sides are equal. So this now becomes my base 1. There's my base 2, 5 plus 8, which is 13. So the formula, area equals 1/2 times base 1 plus base 2, which I've already calculated to be 13, times the height. And the height here is 6. So I'm going to take half of 6 right away, which leaves me with 3. And then we have 13 times 3, which is 39 square feet. That is the area of the trapezoid section. Now I have to add my square, 25, plus the trapezoid, which is 39, and 25 plus 39 equals 64 square feet is our final answer. Here we have a back pocket from a pair of jeans. They're asking us how much material do we need to make 2, keyword, 2 back pockets. So let's find the area of one back pocket, and then we can simply double it. So if I look here, I can cut it. They kind of already showed us the dotted line, so I'm going to cut it right there. And now I have a trapezoid on top and a triangle on the bottom. So let's do the trapezoid on top first. Base 1 and base 2, 12, and this is of course the 10, so they tell us right here. So 12 plus 10 is 22, times a half, which leaves us with 11, times the height, which is 9. And you can see I got the height from right there. So 11 times 9 is 99. So the trapezoid portion is 99 square centimeters. The triangular portion, base is 10, height is 3. So half times base times height. So half of the 10, which really is 5, times the height, which is 3, and 5 times 3, 15. Together, 99 plus 15 leaves me with 114 square centimeters for one back pocket. The question, though, is asking us for 2 back pockets. I need to double that, and I end up with 228 square centimeters would be the amount of fabric I would need, material I would need, to make 2 back pockets. The question only asks for 1 back pocket. Of course, the answer would be half of that, which would be 114 square centimeters. Now, from the actual Chapter 4 test that's in your textbook, or on the virtual textbook, number 1 simply is asking us to find the area of a parallelogram. Formula is area equals base times height. So the base is 130, the height is 100, and we get a final answer of 13,000 square centimeters. You're just multiplying those two numbers together. Number 2 is a triangle. Formula that we're going to use most of the time is area is equal to 1/2 times base times height. Of course, you could always rewrite that as base times height divided by 2, but again, we're going to use that most frequently. So I'm going to take half of one of my dimensions. I'm going to take half of 14, make that a 7. And now I'm just going to do 22 times 7, and that's going to give us 154 square inches. Again, area, you must have square units. Next question, again, that's another trapezoid. So we need to add our base 1 and our base 2. So 1.6 plus 2.4 is going to equal 4 holes. So area is going to equal half times the quantity of base 1 plus base 2 times the height. Base 1 plus base 2 equals 4. Half of 4 equals 2 times the height, which in this case is also 2. 2 times 2, 4 square centimeters is our final answer. Another composite figure. I'm going to cut it, make it into more familiar shapes. 4x4 square on top, 16 square meters. The bottom, base 1 is a trapezoid. Base 1 is 4. Base 2 is 10. 4 plus 10, 14. Area equals half the quantity base 1 plus base 2 times the height. And that equaled, we said 14 when we added them together. Times the height. The height here is equal to 5. Right there. Half of 14 is 7. 7 times 5 gives us a grand total, 35 square meters for the area of that composite figure for the trapezoid part. Now I need to add it to my square part, so 16 plus 35 equals 51 square meters. That actually is the correct total answer for the whole composite figure. Another composite figure, I can slice it right here, and now I have a triangle on the right side and a rectangle on the left side. The base from this corner to this corner is labeled as 14 inches. The height is 8. So 14 times 8, base times height, 32. Here's that. 8 and 3 is 11. So the rectangular portion is 112 square inches. The triangle from the top down, the height is 4. They show me the height from here to here is 4 inches. And I know this base right here is going to match the left side of the rectangle, which is 8 inches. So half of your base times your height. So half of 8 is 4, and 4 times 4 equals 16 square inches. The entire shaded figure is going to leave me, when I add them together, 128 square inches. We also learned in lessons 4.4 how to plot points in a Cartesian coordinate plane. This, remember, just as a side note, is quadrant 1 with the Roman numerals. Top right, always quadrant 1. Top left, always quadrant number 2, Roman numerals. Bottom left is quadrant number 3, Roman numeral 3. And the bottom right is quadrant 4, which is an IV, Roman numeral 4. So I'm looking at question number 7 here. I want to plot point A at 4, 2. Always starting at the origin in the center, 0, 0. Over and then up or down. So over to 4, up to 2, plot it, label it A. B is at 5, 6. Over to 5, up to 6, plot it, label it B. And C is at 7, 4, over to 7, up to 4, label it C. Connect your dots carefully with a straight line if you can, and we have a triangle. I'm going to go ahead and do number 8 now. D is over at 3, up to 4. That's letter D. E is over to 5, up to 8. F is over to 8, up to 8. And G is at 6, 4. And you can see here when we connect these dots, we made a parallelogram. And that's how you plot points on a line. And that's the last practice problem I have here for you. Please make sure you are practicing. You can always go to Google. You can always go to Edline, find extra resources. Come in, ask questions. Be ready for your test. 100%, like always.